Hello, welcome to pre-cal lecture. Oh, got this wrong on here. 4.5b. Evaluating the common log. All right, so we are at the bottom of the 4.4 to 4.6 note package at the bottom of page 3. So evaluating the common log is what we call log base 10. Okay, so our first example is find the log base 10 of 0.0001 without a calculator. All right, so first of all, we want to set this equal to x, like the last homework. So we would have 10 to the x power equals this number that you're taking the log of 0.0001. Okay, so what is the exponent that would give you that? Well, you can kind of think of it like scientific notation. You go this way, 1, 2, 3, 4. So that's going to be to the negative 4. So 10 to the negative 4 is equal to 0.0001. So x is equal to negative 4. All right, so at the bottom of page 3, the common log is written without a base. 10 is understood as the base. So if you just see log written with no base, it's base 10. And you have a special key on your calculator that just says log right up here, just to the left of the 7 on my calculator. That is log base 10. All right. So let's flip over to the next page where it says, we're at the top of page 4, we want to evaluate the log. So this is log base 10 of 1 over 1,000. Okay, so let's set that equal to x. Log, and 1 over 1,000 is the same as 0.001, right? That's 1/1000th. And we're going to set that equal to x. So that's like saying 10, because it's log base 10, just not written, to the x power, the exponent, is equal to 0.001. So that's 1, 2, 3. So x is equal to negative 3. All right, the exponent's negative 3 there. All right, so section 4.5.4 is just, I didn't have a good title for this, so I just called it more complicated logarithmic. Evaluations. They're really not that complicated, they're just more complicated than what we just worked. So our first example, so we are up near the top of page 4 of that note packet, is evaluate 2 times log base 5 of the cube root of 5. Okay, so first of all, let's set this equal to x. And the cube root of 5, it would be very useful if we wrote this as a fractional exponent. That's 5 to the 1/3 power. Okay, so we're going to say 2 times the log base 5 of 5 to the 1/3 power. I'm going to set that equal to x. Now, first of all, I'm not going to worry about the 2. I'm going to worry about that at the end. So let's solve what's in brackets here, and we'll do the coefficient at the end. So this is like saying 5 to the x power, the base to the exponent, is equal to 5 to the 1/3. Well, you have the same base. You know that x is just going to equal 1/3. If you have the same base, you can just set the exponents equal. But now we have to deal with this 2 out front. So you take 2 and multiply it by 1/3. So your evaluation here in brackets was 1/3. Now we're going to multiply the whole thing by 2, and that is 2/3. All right, let's do one more similar to that. We want to evaluate 3/2 times log base 9 of the square root of 9. Now the square root of 9 is equal to 9 to the 1/2. So that's how I want to write this. So we've got 3/2 log base 9 of 9 to the 1/2 power. I'm going to set that equal to x. But I'm not going to worry about the coefficient. I'm going to hold off on that. So it's 9 to the x is equal to 9 to the 1/2. Base to the exponent is equal to what you're taking the log of, 9 to the 1/2. Well, we have the same base, so x is equal to 1/2. You're not done though, because we have to now multiply that by 3/2. Okay, so x now is equal to 3/2 times 1/2, which would be 3/4. All right, so pretty cool. Now we'll go into the last subsection of today's lecture, which we're near the bottom of page 4, section 4.5.5, which is solving for x. In logarithmic expressions. Okay, I've got a little bullet there. So it says when solving for logarithmic expressions, convert them back to exponential form. All right, so convert them back to exponential form. Figure out what the missing piece should be to make the statement true. All right. Well, we're going to do quite a few examples, so you'll be ready for the homework. So our first one is we want to solve for x. We've got log to the base x, so we're solving for the base of 25 is equal to -2. So let's write this as an exponential equation. It's going to be the base x to the -2 power is equal to 25. Now I want to get rid of this -2. Now I know you could probably just figure this out in your head. We could write it as 1 over x squared is equal to 25. But what I want to do is show you a way to do it that'll work with things that are difficult to do in your head. Let's raise each side to the -1/2 power. Now why did I choose that? Well, let me show you. X to the -2 to the -1/2 is equal to 25 to the -1/2. Now those are the same thing because we took each side we raised to the same power, so that's not a problem. But I wanted this to just be x, not x to the -2. So I raised it to a power that when we multiply the exponents, -2 times -1/2, I just get 1. So now I have x it's x to the first power, but just x, is equal to 25 to the negative 1/2. Well, x then would be 1 over 25 to the 1/2, which is equal to 1 over the square root of 25, right? 25 to the 1/2 is the same as square root of 25, which is 1/5. Now we only take the positive answer. So I know that you could square negative 1/5 and also get 1 over 25, right? So, but we're dealing with logs, so we can't have negative bases. This is the base. So I'll write that with logs. We can't, so write this somewhere on your notes in some empty space. Have negative bases. All right, which we had talked about in a previous lecture. All right, I've got 4 more example problems to go with this type of problem in 4.5.5. So turn over to the next page. We're at the top of page 5, and we're just going to work a lot of problems like this and get you ready for the homework worksheet. Okay, at the top of page 5, our example, we want to solve for x log to the base x of 1/16 equals -2. So we want to write as an exponential. So that's x to the -2. The base to the exponent is equal to 1 over 16. Let's raise each side to the -1/2 power. X to the -2 to the -1/2 is equal to 1 over 16 to the -1/2. So you have now the -2 and the -1/2 cancel. We have x is equal to 1 over 16 to the -1/2. Now we can simplify that further, but do you remember one thing that we can do is that we can flip the fraction, so 16 over 1, and make the exponent positive. So x is 16 to the 1/2 power, which would be just the square root of 16, which is 4. All right, so remember we can only have the positive answer. So x is equal to 4. So this is log base 4. All right, and then you can plug it back in to test it and see if it works. All right, next example. We have 4x. I'm going to solve for x is equal to log. The base is the square root of 3 of 27. Okay, so remember this is the exponent, 4x. So I'm going to rewrite it as an exponential. The thing that's just by itself is the exponent. So this is the same as the square root of 3 to the 4x is equal to 27. Now I need them to be the same base. So can I rewrite 27 with a base of the square root of 3? What power would that be? Well, I know that 3 cubed is 27. So the square root of 3 times the square root of 3 is 3, times the square root of 3 times the square root of 3, that would be 9, times the square root of 3 times the square root of 3, that's the same as 3 times 3 times 3, which is 27. So there's 6 of those. 1, 2, 3, 4, 5, 6. So our question mark is going to be 6. So I can rewrite this as the square root of 3 to the 4x is equal to the square root of 3 to the 6th. So we just kind of outsmarted math there a little bit. Now we've got the same base, and we can set the exponents equal to each other. So 4x is equal to 6, x is equal to 6 over 4, and that is reduced down to 3/2. So there you go. Pretty cool. All right, 2 more examples, and then you can work on the homework. Okay, the next one we want to solve for x is log base 64 of x is equal to 2/3. These are a little bit easier, really. We can write this out in exponential form as 64 to the exponent, so the base 64 to the 2/3 power is equal to x. That to that equals that. Okay, so that's going to be the cube root of 64 all squared. Well, what's that? Well, the cube root of 64 is 4. So that's 4 squared, which is equal to 16. All right, last one. We've got log base x of 32 is equal to -5/4. Well, this is probably the fanciest one and probably the best example. So we're going to write it as an exponential. X to the -5/4 is equal to 32. Well, what could I do to both sides to make this just x? Well, I'm going to have to raise it to the -4/5 power, but I've got to do both sides. 32 to the -4/5. So the -5/4, -4/5, those cancel and they're just 1. So we have x is equal to 32 to the -4/5. So now we just got to simplify that. Okay, that's 1 over 32 to the 4/5. Okay, the 5th root of 32 is 2. So this would be the same as 1 over the 5th root of 32 all raised to the 4th power. So the 5th root of 32 is 2. 2 times 2 times 2 times 2 times 2 is 32. And then I've got to raise 2. So what's inside the parentheses is 2. Got to raise that to the 4th power. So 2 to the 4th is 16. So that is 1 over 16. So I don't want you to leave it in this form. I want you to take it to a positive exponent and then simplify it until its most simple form, which is 1 over 16. All right, so your homework, and I don't really have anything to say about it, but it's worksheet, and it is going to be worksheet 4.5b, where there are 10 questions. So give that a go, and I'll make a solutions video for it, and you can watch what you need to watch. So that does it for this lecture. I'll talk to you on the next one.